So we have our steps here. Step one, solve it as if it were an equation. We're going to pretend it's an equal sign. We're going to get rid of fractions by multiplying by the denominator or the LCD if we want to get rid of all of them. Step two, set the denominators. These guys, set them each equal to 0 and solve. So you're going to have a bunch of answers. Step three, plot those answers on a number line and test the areas. And that way you'll know what inequality or inequalities are your answers. Okay, so let's start by multiplying everything by the LCD of 5x, 10, and 2x, which is obviously 10x. So let's multiply everything by 10x. And then let's cancel out whatever we can. So on the first fraction, the 5 and the 10 cancel out. You're going to have a 2 left over. And also the x and the x cancel out. So we really only have a first term of 8. The second fraction, we could cancel out the 10 with the 10, but then we still need to multiply the 1 times x, and we'll have a plus 1x or just plus x. And on the right side, we're going to cancel out the 10 with the 2. We're going to have a 5 left over. That's an ugly 5. But the x and the x also cancel, which means that on the right side, and I want to put an equal sign because step one says to solve it like if it were an equation, we're going to end up with 3 times 5, which is 15. Okay, so now it becomes a simple one-step equation after multiplying everything by the LCD. So let's solve it by subtracting 8 and subtracting 8. So our answer is x equals 7. That's one answer. And ladies and gentlemen, that was barely step one on solving rational inequalities here. Step two is to set the denominators equal to 0 and solve. Okay, so we're going to go back to the denominators. We have a 5x here and a 2x there. And if I write down 5x equals 0, of course, when we solve it, you're going to get x equals 0. So that's another answer. And if you did 2x equals 0, you still get x equals 0 if you divide both sides by 2. So we have those 3 answers, which are really just 2 answers. And if we look at the steps again, the third step is to plot all answers on a number line and test the areas. Okay, so we have our answers. Let's go to a number line here. Let's plot the answers on a number line. We only have the answer 0 and the answer 7. So we need to test values. So we could test the value that's on this side, which would have to be negative. So if I did test, let's say, for example, -1, which is clearly on the left side of 0, let's see if it works. Now, how do we test it? We need to go back to the original and plug in a -1 right there. So instead of 4 over 5 times x, it's going to be 4 over 5 times -1, which is -4/5, right? And you still have the plus 1/10, and you still have the less than, and of course we're plugging in -1 right here, testing the left side of the number line. So you're going to have -3/2 on this side. 3 over 2 times -1 is -2. We're just going to put the negative in front. Now, in order for us to verify whether this is true or false, you could type it into the calculator, or you could get the common denominator. If you want to add these two, you need a common denominator. So the 5, you need to turn it into a 10 by multiplying both top and bottom by 2. So you're going to end up with a -8/10, which is the same thing as 4/5. And now you could actually add it plus 1/10, and it's going to be less than -3/2. If you want, change it to a decimal, -1.5. So when we do add -8 plus 1, that'll be a -7. Okay, so -7/10, is it less than -1.5? Yes or no? That would be no. It's not. Right? This is incorrect. Right? Bless you. -7/10, that's -0.7 if you think about it. And -1/5, that's not -1/5, -1.5, that's -1.5. So -0.7, -1.5, this one's further on the left, this one's less, not greater. Right? So this is a false statement. This is a false statement, so it did not work, which means that this side does not work. So this does not work. That's not part of your answer. So now we need to test a value that's between the two. I'm going to test a value 1, right? So let me test 1, which is right there, and let's see if it works. If it does work, then it might be x is greater than 0 if this works over here. But let's say it doesn't work over here, then it's going to be a compound inequality between the 0 and the 7. I hope this is making sense. Testing the middle area, I'd have to plug in a 1 into our original inequality. So let me do that. Let me plug in a 1. So instead of 4 over 5 times x, it's going to be 4 over 5 times 1, which is 4/5. And then we have a 1/10, no variable. So we have 4/5 plus 1/10. And we do have the less than symbol. And 3 over 2 times 1 is just going to be 3/2. It's easy to plug in 1. And again, in order for us to make sure that this is true or false, we'd have to combine these two fractions by getting a common denominator. I'm just going to do it right here real quick. The 5, I want to make it a 10 by multiplying by 2. The 4, I'm also going to multiply by 2 and make it an 8. So I really have 8/10 plus 1/10. So that's really 9/10. Is it less than 3/2, which is 1.5? Is it less than 3/2? Yes. So this is a yes, okay? Now what does that mean? That means that this middle area, it does work. Yes, okay? So I still need to test one final side. I need to test this last area over here, any number that's on this side of 7. So let's test the number 8, okay? So if I were to go back to the original and plug in an 8 right here, it's going to be 4 over 40, okay? Let's do that. 4 over 40, which we know that reduces down to 1/10. 4 over 40 reduces down to 1/10. And then we have plus this second fraction, which is 1/10. And it is less than 3 over 2 times x, but we said we're plugging in 8. So it's going to be 3 over 2 times 8, which ends up being 3 over 16. Are you with me? Okay, so let's actually do the math here to find out if it's true or false. 1/10 plus 1/10, it's 2/10, which actually reduces down to 1/5. So that's 1/5. And we have less than 3/16. So if you want, you could get a calculator and simply divide 3 by 16 to find out that decimal value. If you do 3 divided by 16 on a calculator, that'll be 0.1875. I just did it on a calculator. And the 1/5 on a calculator, if you go 1 divided by 5, that's 0.2 or 0.20. 0.2 is fine. So the question is this a true statement that 0.2 is less than 0.18? That's false, right? So this is a no. It did not work. So going back to the number line, I know it's a long process, but it will pop up on the final, guys. So this is a no. So the only area that works is the area between the 0 and the 7. So it's going to be a compound inequality, and the answer will be x in the middle, smaller number on the left side, bigger number on the right side, less than symbols. That's your compound inequality answer right there. I hope this helps. Please watch it and practice it over and over.